Welcome to our channel. Today we're diving into the fascinating world of bees. These remarkable insects, architects of intricate societies and vital pollinators of our world, usually exist in a state of harmonious industry. Their lives are a testament to cooperation, a complex dance of roles and responsibilities, all dedicated to the survival and prosperity of the colony. From the diligent foragers collecting nectar to the nurse bees tending the young, every individual plays its part in this miniature marvel of nature. The gentle hum of a healthy hive is a sound of productivity, a symphony of life unfolding. But what happens when this delicate equilibrium is shattered? What forces can turn this usually placid community into a state of alarm, defensiveness, even outright fury? The transformation can be startling, a stark contrast to their everyday demeanor. Understanding the triggers for such behavior is not just a matter of curiosity. It's crucial for anyone who interacts with these vital creatures, whether a seasoned beekeeper or an intrigued observer of the natural world. The reasons are varied, often subtle, yet each can have a profound impact on the colony's temperament. Ever wondered what could make a beehive go mad, angry and crazy? It's a question that delves into the very survival instincts of these complex social insects, revealing their vulnerabilities and their incredible resilience. The hive, a fortress of wax and wonder, can become a cauldron of agitation when its inhabitants perceive a threat to their queen, their stores, or their very existence. Stay tuned to find out as we explore the intricate factors that can unsettle the calm of the colony and discuss how we might help restore their peace. The natural world, in all its breathtaking complexity, is a stage for an unending drama of survival. For the honeybee colony, a rich storehouse of honey and protein-packed larvae, this means the constant, unwelcome attention of predators. These are not abstract threats, but tangible beings driven by their own needs, often oblivious to the chaos they inflict. Consider the bear, a creature of immense power and an insatiable appetite for the sweet reward of honey. Its approach is often heralded by a sense of primal fear, a scent and sound that speaks of danger to the hive's sentinels. The sheer brute force of a bear can dismantle a hive in moments, shattering combs, scattering brood, and sending the colony into a desperate frenzy. The bees, though small, are not without defense. They will mount a furious counterattack, sacrificing their lives in a valiant attempt to drive off the colossal intruder. But against such overwhelming strength, their stingers, though painful, are often a minor deterrent. The aftermath of such an encounter is one of devastation, a community reeling from loss and the arduous task of rebuilding. Then there is the skunk, a more insidious nocturnal raider. It approaches with stealth, tapping at the hive entrance to lure out guard bees one by one. These unsuspecting defenders, emerging to investigate the disturbance, are swiftly snatched and consumed. This persistent nightly predation can gradually weaken a colony, depleting its workforce and creating a pervasive sense of unease. The bees become perpetually on edge, their defensive perimeter constantly breached by a cunning foe that operates under the cloak of darkness. Other creatures too, from raccoons with their nimble paws to the tiny wax moth larvae that tunnel through comb, pose their own unique threats. Each predator, in its own way, tests the resilience of the colony, pushing its defensive capabilities to their limits. The bees' response is instinctual, a collective surge of aggression aimed at protecting their queen, their young, and their precious food stores. This heightened state of agitation is a direct consequence of perceived and often very real danger from the outside world. To shield these industrious creatures from such onslaughts, human intervention can be crucial. A sturdy, well-maintained fence, perhaps electrified, can deter larger mammals like bears, creating a secure perimeter around the apiary. For smaller ground-level threats like skunks, elevating hives on stands makes access more difficult. These simple yet effective barriers allow the colony to expend less energy on defense and more on the vital tasks of foraging and nurturing the next generation. The presence of such protective measures can transform the demeanor of a hive. Relieved from constant harassment, the bees are noticeably calmer, their energies redirected from fending off attackers to the peaceful pursuit of their daily routines. The guard bees, still vigilant, are less prone to hair-trigger responses, understanding that their home is a sanctuary, fortified against the more formidable dangers that lurk beyond. Ultimately, protecting a beehive from predators is an act of stewardship, an acknowledgement of our role in mitigating the conflicts that arise when human activities and wildlife intersect. By providing this security, we not only safeguard the bees, but also ensure their continued invaluable contribution to the pollination of our crops and wild flora, a service upon which so much of our ecosystem depends. The honeybee colony, a marvel of biological engineering, is finely tuned to its environment. Yet it remains at the mercy of a force far grander and more unpredictable than any predator, the weather. Poor weather conditions, whether prolonged or sudden and extreme, can exert immense pressure on a hive, transforming a bustling community into one stressed, agitated, and struggling for survival. Consider a protracted period of cold, damp rain, a common occurrence in many climes. During such spells, foraging becomes impossible. The flowers, their nectaries washed clean or their petals closed against the deluge, offer no sustenance. The bees are confined to the hive, their precious stores of honey and pollen dwindling with each passing day. The internal temperature of the hive must be meticulously maintained, especially for the developing brood, requiring the worker bees to expend vast amounts of energy through shivering thermogenesis, consuming yet more of their vital reserves. This confinement and resource scarcity can lead to a palpable tension within the colony. Conversely, extreme heat presents its own set of challenges. As temperatures soar, the hive can become an oven. The wax combs, the very architecture of their home, risk softening and collapsing. The bees must work tirelessly to ventilate the colony, fanning their wings in a coordinated effort to draw cooler air through the hive and evaporate water droplets, a form of bee air conditioning. This relentless activity is exhausting, diverting bees from foraging and other essential tasks. And if the heat is too intense, the colony can suffer heat stroke, leading to disorientation and increased aggression. Sudden storms with high winds and torrential downpours can be catastrophic. Foragers caught out in such tempests may never return, their delicate wings battered, their bodies chilled. Hives can be overturned, exposed to the elements, their intricate internal structure ruined. The sudden shock and loss can send a colony into a state of high alert, every bee primed to defend what little remains of their ravaged home. The struggle to repair, to regroup, and to recover from such an event is immense. Even less dramatic but persistent conditions, like prolonged drought, can be deeply stressful. A lack of rainfall means fewer flowers, and fewer flowers mean a dearth of nectar and pollen. This scarcity of resources, the lifeblood of the colony, can lead to intense competition, not just within the hive, but also with neighboring colonies. Bees may become more defensive of their limited stores, more prone to robbing other weaker hives, and generally more irritable as the spectre of starvation looms. Providing shelter is a key intervention. A simple windbreak can protect hives from the worst of chilling gales. Ensuring hives are located in areas with good drainage can prevent them from becoming waterlogged during heavy rains. In regions prone to extreme summer heat, positioning hives to receive afternoon shade can make a significant difference to the internal temperature, reducing the burden on the bees to cool their home. These considerations can alleviate substantial environmental stress. In some extreme cases, the most prudent course of action may be to move the hive to a more clement location. While this is a significant undertaking and itself a temporary disturbance, it can be a lifeline for a colony struggling against an unyielding environment. By understanding the profound impact of weather on bee behavior and well-being, we can take proactive steps to mitigate these natural pressures, helping to maintain the calm and productivity of these essential pollinators. The intricate dance between bees and flowers is one of nature's most vital partnerships. For a honeybee colony, the availability of floral resources, nectar for energy and pollen for protein, is the very foundation of its existence. A lack of food, a barren landscape devoid of these life-giving substances can trigger profound stress and consequently heightened aggression within the hive. Imagine a world from a bee's perspective, where every flight is a gamble, a search for sustenance that increasingly yields little reward. When nectar flows are abundant, the colony thrives. Combs are filled with glistening honey, cells are packed with vibrant pollen, and the queen lays eggs prolifically, confident in the colony's ability to feed the resulting larvae. The mood of the hive is generally content, the bees focused on their tasks. But when the landscape offers meager fare, a subtle desperation begins to creep in. Foraging trips become longer, more arduous, and less fruitful, and the returning bees bring little to sustain their hungry sisters. This scarcity, known as a dearth, can be caused by various factors. Unseasonal weather patterns disrupting blooming times, habitat loss due to urban development or intensive agriculture, or simply the natural cycle of plant life in a particular region. Regardless of the cause, the effect on the colony is significant. The queen may reduce her egg-laying, conserving resources. The bees may become more competitive, even resorting to robbing weaker hives in a desperate attempt to secure food. This internal pressure, this gnawing hunger, translates directly into observable changes in behavior. Guard bees become more vigilant, more suspicious of any approach to the hive. The slightest disturbance can provoke a disproportionately aggressive response, as the colony fiercely protects what little it has. This is not malice, but a primal survival instinct kicking in when the fundamental need for food is unmet. The energy reserves of the colony are low, and any expenditure on defense is a costly affair. The importance of a diverse and continuous supply of bee-friendly flora cannot be overstated. Different plants bloom at different times, providing a sequence of resources throughout the foraging season. Monocultures, vast expanses of a single crop, might offer a temporary glut, but are often followed by a sudden famine once their short blooming period ends. A varied floral landscape, rich in native plants, trees, and shrubs, offers a more stable and resilient food source. As stewards of the land, or even in our own gardens, we have a remarkable opportunity to support these vital pollinators. Planting bee-friendly flowers, herbs, and trees is a direct investment in their well-being. Choosing species that bloom sequentially ensures a continuous buffet from early spring to late autumn. Even small patches of wildflowers in urban settings can provide crucial stepping stones for foraging bees, linking larger areas of habitat. By actively cultivating a landscape rich in floral resources, we alleviate one of the most significant stressors for bee colonies. A well-fed hive is generally a calmer, healthier, and more productive hive. The bees, with their larders full, can focus on their intricate societal tasks, their defensive instincts tempered by the security of abundance, ensuring they can continue their essential work of pollination that sustains so much of life on Earth. Within the seemingly impenetrable fortress of the beehive, an unseen battle may be raging. Honeybee colonies, like all living organisms, are susceptible to a host of diseases and parasites, microscopic invaders that can wreak havoc on their health and social cohesion. When disease takes hold, it can profoundly alter the temperament of a hive, turning a once peaceful community into an agitated and distressed one. This is the silent stressor working from within. One of the most notorious of these unwelcome guests is the Varroa destructor mite. This tiny arachnid, an external parasite, latches onto adult bees and developing brood, feeding on their hemolymph and fat bodies. The physical weakening caused by Varroa is significant, but perhaps more damaging is its role as a vector for numerous debilitating viruses. A colony heavily infested with Varroa mites is a colony under siege, its members suffering, their immune systems compromised. The presence of disease introduces a pervasive malaise. Individual bees may be listless, unable to perform their duties effectively. Brood patterns can become patchy and irregular as larvae succumb to infection. The overall productivity of the hive declines, and a sense of disarray can permeate the colony. Bees are remarkably hygienic creatures, and they will expend considerable energy attempting to remove diseased individuals or infected brood, a stressful and often overwhelming task. Other ailments, such as American foul brood or European foul brood, are bacterial infections that target bee larvae, turning them into a decaying infectious mass. The characteristic odors associated with these diseases are a grim indicator of the colony's plight. Nosema, a microsporidian parasite, infects the gut of adult bees, impairing their ability to digest food and absorb nutrients, leading to dysentery and a shortened lifespan. Each disease presents its own unique challenges, but all contribute to a decline in colony health and an increase in stress. A diseased colony is often a more defensive colony. The bees, weakened and perhaps sensing their vulnerability, may be quicker to sting, perceiving even minor disturbances as significant threats. This heightened aggression is a symptom of their internal struggle, a desperate attempt to protect a compromised home. The intricate social order so crucial to the hive's functioning can begin to break down as more and more individuals fall victim to illness. Regular and careful hive inspections by a knowledgeable beekeeper are paramount in the early detection and management of these threats. Observing the brood pattern, checking for signs of parasites like varroa, and being vigilant for any unusual behavior or odors can make the difference between a manageable issue and a full-blown crisis. Early intervention, whether through specific treatments for mites or the removal of infected combs, can halt the progression of disease. Maintaining strong, healthy colonies is the best defense. This includes ensuring good nutrition, providing a clean environment, and practicing responsible beekeeping hygiene, such as sterilizing tools between hives to prevent cross-contamination. By understanding the subtle signs of disease and acting decisively, we can help our bees overcome these invisible invaders, restoring not only their physical health, but also the harmonious balance that characterizes a thriving, peaceful hive. In our quest to control pests and maximize agricultural yields, we have, often unwittingly, unleashed a potent threat upon the honeybee: pesticides. These chemical agents, designed to protect crops, can have devastating and far-reaching consequences for non-target organisms, particularly pollinators like bees. Exposure to pesticides, even at sublethal doses, can cause significant stress and abnormal behavior within a hive, leading to agitation and a decline in colony health. Bees encounter pesticides in numerous ways. They may directly contact sprayed surfaces while foraging or collect contaminated pollen and nectar, bringing these toxins back to the hive. Even water sources can become polluted. The effects vary depending on the type of chemical and the level of exposure. Some pesticides, particularly neonicotinoids, are systemic, meaning they're absorbed by the plant and expressed in all its tissues, including pollen and nectar, creating a poison chalice for unsuspecting foragers. Sublethal exposure can be insidious. It may not kill bees outright, but can impair their navigation, making it difficult for foragers to find their way back home. It can damage their learning and memory, crucial for efficient foraging and communication within the hive. Their immune systems can be suppressed, making them more susceptible to diseases and parasites. Larval development can be adversely affected, leading to a weaker next generation of workers. The behavioral changes can be stark. Bees exposed to certain neurotoxic pesticides may exhibit tremors, paralysis, or uncoordinated movements. They may become unusually aggressive or, conversely, lethargic and disoriented. The intricate social fabric of the hive, reliant on clear communication and coordinated action, begins to unravel. Guard bees may fail in their duties, or the entire colony may exhibit heightened defensiveness as a collective response to the unseen chemical assault. The accumulation of pesticide residues within the hive, in the wax combs and stored food, creates a chronically toxic environment. This persistent exposure can lead to a gradual decline in colony strength and resilience, a condition sometimes referred to as colony collapse disorder, where adult bees mysteriously disappear, leaving behind the queen and a few attendants. The stress of constant chemical assault undermines the very foundations of their society. The most effective way to protect bees from pesticide poisoning is to adopt and advocate for organic and bee-friendly farming and gardening practices. This means avoiding the use of broad-spectrum synthetic pesticides, especially during periods when bees are actively foraging. If pest control is necessary, choosing the least toxic options and applying them at times when bees are not active, such as late evening or at night, can significantly reduce exposure. Creating pesticide-free forage areas rich in diverse, untreated flowering plants provides safe havens for bees and other pollinators. Educating ourselves and others about the impact of pesticides and supporting policies that promote sustainable agriculture are crucial steps. By reducing the chemical burden on our environment, we not only protect the delicate lives of bees, but also safeguard the intricate web of life that depends on their tireless pollination, ensuring a healthier planet for all its inhabitants. At the very core of every honeybee colony resides a single indispensable individual, the queen. She is not a ruler in the human sense, issuing commands, but rather the reproductive heart and soul of the hive. Her presence and well-being dictating the stability and morale of her countless daughters. When issues arise with the queen, if she is failing, absent or deceased, the entire colony can be thrown into a state of profound turmoil and agitation. The queen's primary role is to lay eggs, ensuring the continuation of the colony. But equally vital are the pheromones she produces. These complex chemical signals permeate the hive, informing every bee that their queen is present, healthy and laying. These pheromones suppress ovarian development in worker bees, maintain social cohesion and signal the colony's overall status. Her scent is the invisible thread that binds the community together. Should the queen begin to fail, perhaps due to old age, injury or disease, her pheromone output may dwindle or the quality of her egg laying may decline. The workers, exquisitely sensitive to these cues, will detect this change. A sense of unease begins to spread. They may become restless, less focused on their tasks. If she is laying too few eggs or too many drone male eggs, the workers know the colony's future is in jeopardy. If the queen suddenly dies or is accidentally lost, the impact is immediate and dramatic. Within hours, the absence of her pheromones signals an emergency. The colony becomes audibly agitated, the normal hum of industry replaced by a distinct, mournful roaring sound. Work virtually ceases as the bees realize their reproductive center is gone. This state of queenlessness is a crisis, and the bees will initiate emergency procedures to raise a new queen from young female larvae if available. This period of queenlessness, or the process of replacing a failing queen, is fraught with stress. The bees may become exceptionally defensive as their instinct to protect their vulnerable state intensifies. The normal social order is disrupted. Without a new queen successfully mated and laying, the colony is doomed to dwindle and perish. The uncertainty of this transitional period weighs heavily on the hive's collective psyche. Regular hive inspections are crucial for monitoring the queen's health and presence. A beekeeper looks for evidence of her, a good, solid brood pattern with eggs and young larvae. Seeing the queen herself is reassuring, but not always necessary if her work is evident. If a queen is found to be failing, or if the colony is queenless, a timely intervention called requeening, introducing a new mated queen, can save the colony. Introducing a new queen is a delicate process, as the colony must accept her, but once she is established and her pheromones begin to reassure the workers, calm is typically restored. The bees return to their duties, the sound of the hive normalizes, and the future of the colony is secured. Understanding the pivotal role of the queen allows us to appreciate how her well-being is inextricably linked to the peace and prosperity of the entire superorganism. A beehive is a sanctuary, a meticulously organized society operating within the confines of its chosen abode. For the colony to thrive, a certain degree of peace and predictability in its immediate surroundings is essential. Frequent or jarring disturbances, whether from human activity, persistent animal intrusions, or even vibrations from nearby machinery, can profoundly agitate the bees, keeping them in a constant state of alert and defensiveness. Bees are highly sensitive to their environment. They perceive vibrations through their legs and antennae, and sudden movements or loud noises near the hive can be interpreted as potential threats. Each time the hive is approached or jostled, guard bees are dispatched to investigate, ready to sacrifice themselves to defend their home. This defensive response, while vital for survival, consumes energy and diverts workers from other crucial tasks like foraging and brood care. Consider the impact of a beekeeper who inspects the hive too frequently or too clumsily. While inspections are necessary for colony management, each opening of the hive is a significant disruption. The bees must readjust to changes in temperature and humidity, repair any damage to comb structure, and re-establish their defensive posture. If these intrusions are too common, the colony may remain perpetually on edge, their baseline level of aggression heightened. Animals can also be a source of chronic disturbance. A curious dog repeatedly sniffing around the hive entrance, livestock rubbing against the hive stand, or even wild animals passing too close too often can trigger ongoing defensive reactions. The bees don't differentiate between a genuine threat and a harmless but persistent annoyance. Their response is often the same, an increase in guarding behavior and a greater readiness to sting. Even seemingly innocuous environmental factors can contribute. A hive located too close to a busy pathway, a vibrating generator, or an area with frequent loud noises like construction can create a chronically stressful environment. The constant sensory input keeps the bees in a heightened state of awareness, unable to fully relax into their normal routines. This can lead to a more irritable temperament overall as the colony's collective patience wears thin. The solution lies in thoughtful hive placement and respectful interaction. Selecting a quiet, sheltered location for the apiary, away from high-traffic areas, both human and animal, and sources of constant vibration, can make a remarkable difference. Hives should be positioned to minimize the need for people to walk directly in their flight path. Providing a natural barrier, like a hedge or fence, can also help to create a sense of seclusion for the colony. When hive inspections are necessary, they should be carried out calmly, efficiently, and with gentle movements, ideally on warm, sunny days when many foragers are out of the hive. Avoiding jarring motions, excessive smoke, or prolonged exposure of the brood nest helps to minimize the stress on the colony. By understanding and respecting the bees' need for a stable and relatively undisturbed environment, we can foster a calmer, more manageable, and ultimately healthier colony. A honeybee colony is a dynamic, growing entity. Under favorable conditions with a prolific queen and abundant forage, the population within the hive can expand rapidly. This growth is a sign of success, but if left unmanaged, it can lead to a critical issue: overcrowding. A hive that becomes too congested can transform into a stressed, agitated, and potentially aggressive environment, as the bees' natural instincts for expansion are thwarted. Imagine a bustling city with its infrastructure strained to the limit. This is akin to an overcrowded beehive. The available comb space for brood rearing and food storage becomes scarce. Nurse bees may struggle to find empty cells to care for larvae. Foragers returning laden with nectar and pollen may find no place to deposit their precious cargo. This internal competition for space creates a palpable tension throughout the colony. Overcrowding is a primary trigger for swarming, the natural method by which honeybee colonies reproduce. As the hive becomes congested and the queen's pheromones are less effectively distributed, the bees begin preparations to divide. They will raise new queen cells, and a significant portion of the colony, along with the old queen, will depart to find a new home. While swarming is a natural process, the period leading up to it can be marked by increased defensiveness. The bees in a crowded hive may seem more irritable, more easily provoked. The sheer density of bees means more guards at the entrance and a quicker, more overwhelming response to any perceived threat. The internal environment can also become more challenging to manage, with increased humidity and difficulty in thermoregulation. This physiological stress can further contribute to a more aggressive temperament. A lack of space can also stifle the colony's potential. If the queen has no room to lay, the population growth will stagnate, and the hive's ability to gather surplus honey will be diminished. The bee's natural drive to expand and build is frustrated, leading to a kind of collective restlessness. This can manifest as an increase in bearding, where large numbers of bees cluster on the outside of the hive simply because there is no room inside. Effective hive management by the beekeeper is key to preventing the negative consequences of overcrowding. This involves regularly assessing the colony's population and the amount of available space. Adding new hive boxes, supers for honey storage, or additional brood chambers in a timely manner provides the bees with room to expand, alleviating congestion and reducing the swarming impulse. Another crucial management technique is splitting the hive. This involves dividing a strong, populous colony into two or more smaller colonies, each with its own queen or the resources to raise one. This mimics the natural swarming process, but in a controlled manner, relieving population pressure in the parent hive and creating new viable colonies. A colony with ample space is generally a more contented, productive, and calmer colony, able to focus its energies on growth and foraging rather than the stresses of confinement. The world of the honeybee, so intricate and vital, is a delicate balance of industry and instinct. As we've explored, numerous factors can disrupt this equilibrium, leading to a hive that is agitated and defensive. From the looming shadow of a predator to the invisible grip of disease, from the pangs of hunger to the constraints of a crowded home, each challenge tests the resilience of these remarkable creatures. Understanding these stressors is the first step towards fostering a more harmonious coexistence. By recognizing the signs of distress and implementing thoughtful, proactive measures, whether it's providing security, ensuring ample food and space, or maintaining colony health, we can significantly alleviate the pressures that lead to bonkers bees. Our role as observers, gardeners, or beekeepers is one of stewardship, a responsibility to create conditions where these essential pollinators can thrive, not just survive. The calm hum of a contented hive is its own reward, a testament to a partnership well managed. Thanks for watching. If you found this video helpful in understanding the complex lives of bees and how we can support them, don't forget to like, share, and subscribe for more amazing content about the natural world. Your engagement helps us continue to bring these fascinating stories to light. Stay curious and keep exploring the wonders that surround us, from the smallest insect to the grandest ecosystem. There's always more to learn, more to appreciate.